What is going on YouTube? This is the Middle School Math Man. This video is going to be on quadratics, but more specifically, we're going to talk about the transformations of these parabolas. So we're going to look at two main parts. We're going to look mostly at the slope and how it affects the parabolas, and also the y-intercepts, how those are going to affect what the parabolas look like. So you're going to see what this means in a second once we actually start doing some problems. But the slope really changes we'll call it the steepness. So for example, if you have a line that has a slope of 2, that line that has a slope of 2, if I do a rough little sketch over here, a line that has a slope of 2 is going to look, I don't know, something like that, whereas a line that has a slope of, let's say, 1/4, that slope is going to be much more flat, much less steep. So the slope is going to affect what our U-shaped parabolas look like, whether it's going to be steeper or it's going to be more spread out. And then the y-intercept is going to shift our parent function. We'll talk about a parent function, but it's going to shift our parabola up or down compared to that parent function. So those are the two main things we're going to be looking at. So this first problem, it gives us 3, and then I added a fourth equation. But first, we talked about that parent function in the last slide briefly, but the parent function is y equals x squared. So that is just our basic parabola. The y-intercept is 0. Now you could graph all these by hand if you create a table and you plug in your x values for each of these parabolas. Just for the sake of the length of this video, I'm going to just graph these roughly just so you can see. The main point of this video is to see, like I mentioned, the steepness and also how it shifts. So my graphs don't have to be exactly perfect, but I'll try to make them as close as I can. So the parent function, if we were to graph that, I know there's going to be a point here on 2, 4, negative 2, 4, and I got that just by thinking to myself, if I plug in 2 for x, 2 squared would be 4, so 2, 4, same thing with negative 2. And then I could go a step further. If I plugged in 3, it would be 9. So this is just a rough sketch of what that parent function is going to look like. So if I graph A, I'm going to do that in this dark blue color, y equals negative 3x squared. So you should notice the main difference between A and the parent function is that negative 3. So what is that negative 3 going to do in comparison to the parent function? Well, you know that the parent function has a slope of 1. So negative 3, it is negative, but 3, if you think about if you were to graph a slope of 3 on a graph, you would go up 3 and over 1. So that should be a lot more steep than if you were to just go up 1 and over 1. So this graph of negative 3x squared, with all of these graphs, we all have a y-intercept at the origin. So if we were to plug in negative 3, this is just going to be a very rough sketch. So if I'm trying to graph y equals negative 3x squared, some of the points that'll be on this graph are If we plugged in -1, we would get -3. So that point's going to be right there. If I plugged in 1, I would get -3 as well. Now when I plug in -2, I'm going to start getting some bigger y values that don't show up on this graph, but it would be somewhere down here. So again, this is just a rough sketch. But a couple of very interesting things on this graph. That negative number, anytime that A is negative, we're going to see this with C also, the parabola is going to open up down. Also, you should be able to see that this parabola in dark blue is a little bit steeper than the parent function, and that's because the slope is -3, and that is going to be steeper than something that has a slope of 1. Alright, let's graph B in green. So the y-intercept is 0 again. So 1/4 x squared. So that a value, that 1/4 is positive, so we know it's going to open up. So if you were to create a table, you would figure out what the points are on this graph. Just for the sake of time, I'm going to just give you these points because, again, the point of this video is to see what these numbers are doing to the graphs, not so much how to graph them. So again, this is a rough sketch of what y equals 1/4 x squared will look like. The y-intercept doesn't change, it's still 0. And as you can see, this graph is much wider than the parent function. It's much less steep, and that is because that slope of 1/4 is going to make it a lot less steep than something that has a slope of 1. Compare B, compare the slope of 1/4 to a slope of -3, it's even less steep because -3 was steeper than the parent function, so a slope of 1/4 is going to make it a lot less steep. Moving on to C. Try to think in your head what this is going to look like. We know it's negative, so we know it's going to open down. It's going to be similar to B because it's the same slope, it's 1/4, but it's negative, so it's going to be the same thing as what we have in green, except now it's going to open down. So starting at the y-intercept, so my first point is going to be -2, -1, and 2, -1. The next point is going to be -4, -4, and 4, -4. So here's a rough sketch of what that'll look like. So it is the same looking, steepness as B because it's the same slope, 1/4, except because it's negative, it's going to open down. And I just wanted to include one more. I'm not going to graph it, but I just want you, if you want to pause the video and think about what y equals 5x squared is going to look like. So D, what is that going to look like? Well, if it has a slope of 5, first of all, 5 is positive, so we know it's going to open up. And a slope of 5, that would be the steepest one on this graph. Because that slope of 5, obviously, if you think about graphing a line of the slope of 5, we're going to go up 5 points and only over 1. So that's going to be a lot more steep than something that has a slope of 1/4 or 3 or even 4. So the slope tells us the steepness. The last part of this video is going to talk about the y-intercept. So the y-intercept, if we go back a couple of slides, the y-intercept is going to tell us whether it's shifting up or down. So remember, the y-intercept is where something crosses the y-axis. So if we were to graph our parent function, just a quick rough sketch of the parent function. Our y-intercept is 0. I have a point at negative 2, 4 and 2, 4. So I'm just going to roughly sketch what the parent function looks like. So all of these have the same slope. So they're all going to be the same steepness, but they all have different y-intercepts. So if we have a y-intercept of 8, so y equals x squared plus 8, the only thing that's going to change is now instead of my y-intercept being at the origin, the y-intercept is 8. So it's going to shift it up 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. So there is where the y-intercept would be. Now the points are going to go off this graph, but there is just a very rough sketch of what that parabola would look like. B is y equals x squared minus 5. So the same slope, but the only difference is that y-intercept of negative 5 is going to shift it down 5 units. So again, another very rough sketch. The point of this is to just look at the y-intercept and how it changes things. If you would like to pause the video and figure out and see on your own, that is a great thing to do. I'm going to do this in green. Again, another very rough sketch, but this y-intercept of negative 10 is going to shift it down 10 units. So there's the y-intercept, another very rough sketch. It would look something like that. So again, just a quick review. The two main things when we're talking about how a parabola is transformed or how it compares to the parent function, we're going to look at two main things, the slope and the y-intercept. So the slope will tell us is it more steep or less steep, by how much, and also the y-intercept will tell us if it's shifted up or down and how many.